Hey team, so here we go. We're going to be multiplying again with the traditional algorithm. This time we're going to have a two-digit number. 24 has two digits, a 2 and a 4, by another two-digit number of 12. And what's going to happen is we're going to kind of build on what we know about multiplying by or with the traditional algorithm. And then we're going to kind of take it one step further. So, what we know already is that you look to the digit in the ones place value spot of the second number. So, these happen to be stacked up. We're going to call 24 our first number and 12 our second number. When I set these up, I like to personally put the bigger number on top. If I just have two numbers that both are two-digit numbers, I prefer to put the bigger one on top. It doesn't actually matter, right? You're going to get the same thing, but it's just a personal preference. So whichever way you set it up, whichever digit ends up here in this ones place value spot of the second number, you're going to start there, right? And then just like we know, we're going to multiply it by all of the parts of this 24. And using this algorithm, right, what's kind of handy is we don't really have to remember that it's a 20 and a 4 like we do when we're using the other methods like the area model. We'd have to break it up into a 20 and a 4, or using the partial product method, we would need to remember that it's a multiplying by a 4 and a 20. But in the traditional algorithm, handy dandy, you can just kind of go for it. You just have to do it in a certain order. So we're going to take that 2 and multiply it by what's above it first. 2 times 4 is 8. And then we've essentially multiplied it by this part of 24. And then I like to I don't know, I like to color things. So we're going to then say, well, what haven't we multiplied this 2 by? Well, we haven't multiplied it by this 2 or this 20. So we're going to say 2 times 2 is 4. And handy, it ends up in the tens place value spot, telling you it's really a 40. So 2 times 48, or sorry, 2 times 24 got us 48. But now we want to make sure that we multiply by all of the parts of this number, right? We've multiplied 24 by 2, but we haven't yet multiplied 24 by 10. So we're going to go ahead and make that happen. So I'm going to say, okay, let's just get rid of this to make a little more space. And as we look, we're going to say, okay, oh, I just said something. That's not really a 1, it's really a 10, right? So that's a super handy thing to say out loud to yourself or to remember that this is a 10. So we're going to put this sort of placeholder here of a 0 telling us it's not a 1, it's 10. And once we put that placeholder there, we can kind of magically go, poof, it's back to a 1, so that we can multiply just by our basic facts. So 1 times, we're going to go to the smaller first. We're going to go to the ones place value spot first. So 1 times 4 is 4. So check, we've multiplied by this 4. Yay. And now the only thing we haven't multiplied by, the 10 by, is this 2, which is really a 20. But in this case, using the traditional algorithm, it doesn't really matter. We can just see it as that basic fact. So 1 times 2 gets us 2. And now we say, okay, cool. So essentially 10 times 24 is 240 and 2 times 24 is 48. That's what we've done. And now we want to add those together. So we're going to say, okay, 8 plus 0 is 8 and 4 plus 4 is also 8 and 2 plus nothing is 2. So in total, we end up here with 288 when multiplying a two-digit number by another two-digit number using the traditional algorithm.